All right, so Grand Forks, with a little help from Right Away Division, is going to go over some things regarding ADA curb ramps. I'm going to be doing survey design. Right Away is going to go over curb ramp exhibits, and Ethan and Mark will finish up with construction inspection. This is what it all boils down to here is compliance with ProAg. Everything we're trying to build and do is to comply with these guidelines, primarily section 3 and 4 on this website will show you what you're trying to build or maintain. We're mostly going to talk about revisions or retrofits in this presentation because that's mostly what we do at this point. But these guidelines apply to new construction and revisions. So any questions, all the answers come from here. I mean, even if you're looking at standard drawings or a design, if you don't understand something, we're trying to comply with this, just it all comes back to this website and these guidelines. So when you start a project, it starts off with an evaluation of the existing curb ramps and access. Everyone knows the basics. We want a ramp that's less than 8.3%, and we want turning spaces at the tops of the ramps that are, less than a 2% cross slope. We typically go out with a smart level. We lay, you can't just put it in one spot or move it around until you find that magic number you're looking for. We lay the smart level across the ramp, 3-4 spots across it, and then same cross slope. You go up and down, checking the cross slope, checking the whole ramp to make sure the whole ramp is compliant, 8.3% or less for a ramp, and then 2% for cross slope everywhere, not just in one spot. Some kind of other things you should be looking at when you're evaluating existing facilities. You want a minimum 48-inch width. This 5% running slope is kind of key. If it's less than 5%, it's not a ramp, and then you don't have to worry about turning spaces, especially in Grand Forks and pretty flat. We have a lot of curb ramps that aren't actually ramps. They're just, and then we still have to keep the slopes and cross slopes in compliance, but we don't have to worry so much about turning spaces in some locations. So just remember that if it's less than 5%, it's not a ramp. Another one is the 48-inch minimum clearance around obstructions. So an example here, we have our sidewalk coming in here. We have an access around to a turning space here. Our ramp slope is good. Geometrically, all this concrete's in good shape. Unfortunately, someone plopped a stop sign right in the middle of our access route, and now we're out of compliance on this location. So that's something that would need to be revised, either move the stop sign or, put a little more concrete here to give a little more access width. Another thing to be looking at are push buttons. ProAg requires not necessarily a full turning space, but a minimum 30-inch by 48-inch level spot of less than 2% slope around the push button so people can, use it. An example here along the highway, kind of maybe have our 2% spot here at the top of the ramp, but then the push button's in the ramp. The fix here was simply to extend the turning space past the ramp so it could be reached from the turning space. So that was something to consider when doing that design. ProAg also talks about vertical change in level, which also would apply to faulting. You're allowed a 1/4 inch max change in level or fault. And if you bevel the edge, you're allowed a 1/2 inch, which isn't a whole lot. A half inch at 2 to 1 is not much bevel, not much vertical change. So some of the places where this pops up, here, sometimes it's obvious. We got a 3-inch drop here, it's not finished nice. It jumps right out at you. This is out of compliance. Some places it's not so obvious. This doesn't look bad. It looks fine, but when you put the level on it, there's more than a half-inch vertical change in level, and it doesn't meet those bevel and slope requirements. So that's out of compliance. And then kind of the last guideline I wanted to bring up when evaluating existing facilities is grade breaks. Grade breaks need to be perpendicular to the direction of travel. Some examples of these problems are like here, pedestrians are coming this way. If you assume the pedestrian travel is just keep going straight, you're gonna have a cross slope problem. The ramp slope is fine. There might be a turning space, but the turning space should be back here behind the direction of travel, which is obviously intended to be, at a slant. So this is non-compliant. And this is another example on the next picture. We got, if we were coming down the sidewalk from either direction, the cross slope would be bad. Our grade break probably looks something like this. So our turning space, if our ramp direction's this way, our turning space should be here, but we have a kind of a V-shaped grade break, and this is out of compliance. When evaluating curb ramps, sometimes the best solution is just to eliminate the ramp or consider the possibility that it's not the responsibility of the DOT. Some examples here, this is a bus stop in Grand Forks. There is an existing ramp here. We were supposedly directing traffic out into 6 lanes of traffic and no median crossover. On top of that, in order to maintain this ramp, I would have had to have lowered all of this concrete around the bus stop. And I don't think we have a bid item for remove and reset bus stop, but it was just going to be a giant problem to maintain that ramp. Well, looking into ProWag, because we don't have a standard detail for this, going back to ProWag, this is the preferred method for, bus stops, train stations, subways. You have your vertical edge, you delineate it with a detectable warning panel. And the fact that I didn't have to lower traffic down to, gutter line level, because we really don't want them walking out onto 32nd Avenue. It gave me an extra elevation to play with, and I didn't have to mess with this bus stop. So talking with the city of Grand Forks, we're like, we're gonna make this change to your bus stop, and they actually preferred it. And they also said their buses lower to curb height to make it easier to get on. So if we were to actually put a ramp in here as it was originally, it makes it actually less accessible. So sometimes it's just to consider, do we even want to be putting curb ramps in and directing pedestrian traffic somewhere? In this case, we did not. Another example of eliminating a curb ramp, the curb ramp in question down here, obviously very tight space. As usual, when you have your curb and gutter abutting or your sidewalk abutting the curb and gutter, we've got a fiber optic vault here, which limits our options for putting bump outs or turning spaces. There are just utilities in the sidewalk. It's a mess. Well, we look across the street where there was a reconstruct a couple of years ago, and they eliminated the pedestrian crossing here at this non-signalized intersection. So we took our cue from that, talked to the city and our design engineer, and it's like, maybe the best solution is just to eliminate this crossing. And everyone agreed that we don't want to be encouraging pedestrian traffic across, 5-6 lanes of traffic downtown at a non-signalized intersection. So now we redesigned this just to carry pedestrian traffic across the street. and everything got easier. Here's another example of eliminating an unnecessary curb ramp. We got an old sidewalk coming in here right on top of an inlet. Just going to be messy. Across the street, there is no receiving ramp. So the solution here was just to rip out the concrete, put in topsoil, and plant it back to grass. There's no point in sending traffic into a street where they have nowhere to go. And then across the side street from here, we have this location. We have a private property. They've got a nice decorative landscape block retaining wall here. Someone came in and put in a newer ramp here. We got the older ramp here. However, it's too steep. In order to fix this, we would have to have lowered this landing, which would have impacted this retaining wall. Again, there's no receiving ramp across the street. So we simply removed this ramp, planted it back to grass, and then, retrofitted a panel into this location, and thus avoided the headache and cost of redoing this guy's decorative retaining wall. And then some locations where we probably just shouldn't be doing work at all. Businesses, homes, churches are all examples of private property that may build their own access to the road. That doesn't mean it's our responsibility to make it compliant. Years ago, when we first did ADAs, someone decided to put in a ADA ramp here with good intentions, obviously. Well, 15 years later, we come back and it's, needs to be maintained. Because of slopes, I had to lower kind of the landing space here, which meant redoing this concrete as well back to their sidewalk. So what I have here is kind of their landing. I had to put a ramp in here, make a landing here, and then ramp back down here, back down to the street. And of course, that involved changing the grades of the sidewalk here. All of this work was probably never should have been our responsibility. This is a private access, but we kind of bought it by making these improvements 15 years ago. Here we have another church that we ran into the same situation. Someone was thinking that maybe we had to put a ADA curb ramp in here. Because of the width and the cross slope of the sidewalk, we were going to have to lower this, redo this concrete, which would have impacted their sidewalk to their front door. I mean, we were looking at replacing this wide sidewalk all the way back here. Kind of a lot of concrete to replace, and I guess I kind of made the argument that this is a private access point. This isn't our responsibility. This isn't where our right-of-way crosses another right-of-way. So we just did not even dig into this. So just kind of some examples of sometimes it's just we shouldn't be digging into an area. After I evaluate all the corners along a project, I tend to put together a little report of what I found at each area, what's out of compliance, and then I know where I have to go survey or send the surveyors to get data for design. So that's kind of all I had on the initial evaluation. We do have an SX10 scanner for our use in the DOT. So I was just going to show some things with that. Can be used for both initial evaluation and design. Here I set up the scanner between two curb ramps where I could see longitudinally down the sidewalk, and you get some pretty nice results. I mean, you can measure the fault here by clicking on points across the fault. I can measure the lip. I get widths. I can click between any 2 points anywhere in any direction and get slopes. And of course, you can draw off this too for your geometric design. It worked good for when the sidewalk abuts the curb. It worked good. I was able to get 4 quadrants from one setup, other than maybe a little nerve-wracking setting up a $30,000 total station in the middle of the road. But collected a lot of good data where I could measure faults and lips, get slopes. Some spots where it does not work so well. I thought I was going to get all four corners from one setup here. You can see tall grass created some shadowing where the scanner was not able to collect data. In this situation, I probably should have done 3 setups, not 1, in each quadrant here, so I could look longitudinally down. But I only did 1, and you can see by all these black areas, I'm missing about 1/3 of the data I should have. So if you decide to use the scanner for your survey and evaluation, just some things to keep in mind. You'll probably need more setups than you think. And then, I don't know, someone took over. All right, try again here. This particular corner was one of 4 that I scanned from one setup. Obviously, the existing sidewalk was in terrible condition, lots of weeds, tall grass. There's a messy tree here that dropped all kinds of crap, and the scanner just did not collect much useful data. So just another consideration, you need to clean off the sidewalk if you're going to use the scanner. So I've evaluated all my corners. I'm going to go out and survey for design. In Grand Forks, we prefer to perform our ADA survey with the total station. We found that the tendency of the user to reduce shot times, 3-second shots, rapid topo are not going to give you reliable vertical results. Poor PDOP caused by obstructions and like buildings and trees, longer baselines if you're using the VRS for corrections. I mean, and even lately, it seems like there's been a lot of increased solar activity, are just a few of the factors that will reduce the confidence in the vertical accuracy of GPS measurements. Your data collector will be hollering at you about high RMS. Even under good conditions, clear skies, the vertical accuracy of GPS is, probably around 500ths. A difference of 500ths across a 5-foot sidewalk means if you think you're measuring a 2% slope, it might be anywhere from 1% to an unacceptable 3%. So we've just found that the problems with vertical reliability of GPS, for this purpose, it's worth taking the extra time to set up the total station and get good results. I've sent techs out to survey, and they come back and tell me a cross slope is 12%. It's like, I don't really believe a sidewalk has a cross slope of 12%. Take the level and go back out there. So, I'm not really going to go over much survey, just a few tips. Don't forget your line work codes, plus and minus to begin and end lines, and the shapes, the plus and exclamation to close shapes. Pretty common. Everyone knows about those. What's probably less used are the forward slash and backslash for inserting arcs into our line work. You can shoot curb and gutter with, take shots on tangent. You come to the beginning of the radius, put a forward slash in, shoot a couple, 2, 3, 5, however many points on the radius you think you need. End the curve with a backslash, and then end the line somewhere down the tangent with a minus. And it'll draw a nice either radius, or if it's an S curve, it'll draw a best fit curve if you keep shooting points on the curve. Just kind of a heads up, the curb and gutter codes assume that you are shooting the flow line and the back of curb is on your left as you shoot the flow line. Some other tips for design, as well as that'll help in construction: shoot your flow line well before and well past the planned work, so you can confidently determine the flow and mark it in the plans. It comes in useful for design as well as determining if you need inlet protection. I like to specifically take shots at these points where, your 5 or 6 foot sidewalk intersects the curb and gutter. Assuming there's no flow problems or ponding that you're going to try to fix, these are typically going to be your takeoff points for your design. And then when you're shooting curb and gutter, you'll need to also, if the sidewalk abuts the curb and gutter, you'll have to take spot shots at the top back of curb as well to check cross slope in those areas. So we've got all your survey and we're going to jump into design. I can't stress enough to review ProAg and our standard drawings. Some things do get updated. Hopefully we're to the point now where there'll be fewer changes than there have been over the past 10 or 15 years, but you need to make sure you're staying current. Here's kind of a part of our standard drawing. Got our 5 major types of curb ramps, and they're kind of, type 1 is kind of the preferred way of doing it. If you can't make one of these work, we go to type 2. If we can't make that work, go to type 3. Type 4 is the least preferred method of doing curb ramps at a corner. There's some guidelines on here that you should be aware of. 8.3, like for example, 8.3 is the ramp limit, but we don't want to design to the max. We prefer to design between 5 and 7, I think it says, or 5 and 7.5. Cross slopes, 2.1% is the limit, but when we're designing, we want to maybe keep it around 1.5%. Give yourself a little room when you're doing work, and also if things shift or heave over time, hopefully they stay in compliance. So we've done our survey, we've imported our line work. Just a couple tips I want to throw out here. If you survey a curb and gutter walking in the wrong direction and it comes in backwards, there is a curve toolbox in MicroStation that has a change curve direction command that will flip this back to the correct direction, put the gutter pan on the street side and the back of curb where it belongs. Also, if you overextend taking your concrete shots, I went around here, I have an extra concrete line, I just kind of trim that out. So here I've flipped my curve using that command. If I did it wrong, I've trimmed out the extra line. At this point, I like to draw in where my pedestrian access routes are probably going to be. And then I also label the key points. These are the existing elevations that I probably want to tie back into if possible. So I've labeled all that, and then on this side, I've labeled my potential tie points in to tie back into existing. So I'm starting here at this corner at 1523.77. I usually start with the shortest leg. Generally, that's going to control, not always, but got to start somewhere. So I start with the shortest leg, go up my 5% because that's our preferred slope, and I calculate a proposed elevation for my landing. And I usually leave those as just 4 digits to kind of differentiate calced positions versus surveyed positions. From here, the general tendency is going to be to take your 1.5% this way and 1.5% this way to get your other corner. However, the ProAg requires a max of 2% in all directions. And on a 5x5 landing, if you go 1.5% this way and 1.5% this way, you're going to end up with 2.1% cross slope in this direction. And you're basically a little out of compliance at design. So what I like to do is go from this corner to this corner at 1.8%, and that's because this is 5x6, it gave me a 1/1400th difference. And then I just split that for these 2 corners. So these are now 7/100ths between. So now I have my proposed elevations of my landing, and then I label that out. You can see that I went 1.8% across here, and that gave me 1.2% cross slope this way and a 1.4% cross slope this way. Everything's acceptable there. Now I come back here and I check my tie-ins. From this elevation back to existing, I got a 7% slope. You know, that's in the preferred range, well under the limit. Go back here, I'm a lot flatter. From this point, this is our primary concern. We are, as the DOT and on our projects, we are to make access to our right-of-way compliant. But once you've got these landings in and you've got your ramps in, you still need to tie back into, you know, the city sidewalk or private infrastructure to tie back in. So the goal here from your landing is to tie back into existing as soon as reasonably possible. It's not our responsibility to chase out of compliance sidewalk all the way down the block. And in fact, it would be bad if we did that. If we start replacing too much sidewalk, someone's going to come in and expect us to evaluate the whole corridor. And then you're going to have people wondering why you're replacing some sidewalk and not theirs, you know. So this is our primary responsibility. Then using our guidelines for transition panels, where we need to tie back into existing infrastructure as soon as possible. In this instance, I knew I was tying back in here because everything was just too crumbled. I had nothing to tie in here. So I used these elevations. I came up with my slopes. Everything's acceptable. You know, I don't need any extra ramp or turning space. I'm able just to tie right back in here. On this end, you can see I had some additional survey. I determined I was able to tie back in at this point and maintain an acceptable slope. I've got all my lengths and my slopes are all calculated here. Everything is compliant. You can see I'm 3% cross slope here. We are allowed to transition from an acceptable 2% to an existing cross slope at a 0.5% per foot. So as long as your grade doesn't exceed 0.5% per foot, we are not obligated to chase replacing city sidewalk or private sidewalk to an acceptable 2%. We transition from our whatever slope we have here at no more than 0.5% per foot to a good tie-in point. So that's kind of the guidelines there. So everything fits on this particular corner. And then it's a matter of finishing out all the labeling. There is a legend on the standard drawing. There is an ADA toolbar in MicroStation. It's currently broken, so I wasn't able to really get any examples. John's aware of that, and he's working on getting it fixed. But every panel needs to be labeled, whether it's a ramp, a landing, a transition panel. We have 10-to-1 flares when if you 10-to-1 flares if you're coming back to surfacing in this area. Another transition panel. You know, if it's a grass boulevard, you got your 4-to-1 flare, which you label. Curb elevations, obviously we tie back into 6-inch curb here, 0, 0. I went with a 3-inch curb here because I don't think I had the room to go to a 6-inch curb. Going back to 6 is preferred. Going to 3 is acceptable to delineate the pedestrian access route if that's what fits. Back to 0, 0 across the ramp and back up to a 6-inch curb. And then, of course, I've shown them here that the flow goes around the corner this way. And this is nice to have. No plan is perfect. If they were to have to make any adjustments in the field, knowing ahead of time where the water goes would save them the time of having to, take the level out and figure that out for themselves. This location also had a little bit of retaining wall around the corner, so I put in the plans an area of that for replacement as well. But this is more or less completed. Obviously, it was a pretty simple corner. There's 1,000 scenarios, and we can't go through them all, but I just kind of wanted to hit the highlights of checking grades, labeling all the grades, labeling all the lengths, labeling all the panels, and that there are tools in MicroStation under the curb ramp toolbar, or there will be when that gets fixed again. So you've done your survey and you've been working on the design and you've been beating your head against the wall because you just cannot make it meet ProWag. Well, we do have a tool for that. It's called the Maximum Extent Feasible Technical Memorandum. It's just a design memo. When you come to a situation that you cannot meet ProWag, it's kind of a standard form. You put the project info in. We basically just state we tried to meet ProWag, we tried to meet ADAG, which is the original accessibility guidelines. ProWag kind of builds on those to be more specific to, streets and sidewalk. If we can't meet that, then our goal is to meet maximum extent feasible. So you and your team, maybe the design engineer, have talked about this. We can't meet ProWag or ADAG. We're going to have to find a different solution. A common example is when existing streets are steeper than 2%. Obviously our ramps aren't supposed to be more than 2%, but you can't tie a 2% ramp into a 5% street. So this isn't even about reinventing the wheel. In this case, Oregon had guidance for using a tilting ramp to blend into the street. We basically just said this is what we're going to do, and then another section we just listed out the corners that had this problem, showing that we're going to use a tilting ramp. Short and sweet, nothing too complicated. Tech support signs it, and then design division signs it. And designer, tech support, and design division sign it, and basically we're just saying that yes, we've all agreed that this is the best we can do under the current circumstances. It also depends a little on the scope of work. Here's an example where we did a maximum extent feasible where we just did nothing. There's a grocery store here. They've got their access is right on the corner. There is no way to lower this slope and create landings that does not negatively impact the access to this private business. So we did a memorandum that said we can't do it, and that was fine for a preventive maintenance project, but maybe in the future there's a reconstruct and they do a bump out to move this ramp away from this access, and then maybe that's what they fix it in the future. But maximum extent feasible will depend on your project and the scope of work and the scope of your project. So just some things to consider. I don't know. If you can't design it and you talk to design division and they agree you can't design it, we have this tool for not doing anything in certain circumstances. Just a few other things on the design. We got include design division in PS&E reviews. Right now it's Jen Enrheim and Sarah Kalin do a lot of the reviews of ADA ramps specifically for us. Request special provisions, especially when doing curb ramps along asphalt surfacing. I like to request the commercial grade asphalt SP so they can fill, they remove more surfacing than they need to get the formwork in, and then we need to fill in behind the formwork. So a commercial grade asphalt SP comes in handy, or perhaps for, patching bike paths after you redo a curb ramp. Temporary pedestrian facilities is the traffic control SP. We used to have to do fairly extensive design work for temporary pedestrian facilities. Now you can request the SP, include 3 bid items and 3 standard drawings, and that's pretty much all you have to do for temporary traffic control. It just describes what they have to do to maintain access. I've also been told by Jen that we are going to start including utility coordination SPs in all curb ramp locations. What that SP contains will change from job to job, but we need to request it. Some other useful plan notes. In Grand Forks, we're doing order of operations. We want the curb ramp done before any adjacent surfacing. In particular, your vertical elevation change requirements apply to the entire pedestrian access route, not just the curb ramp. And we have a way easier time getting an acceptable transition if the curb ramp is done first. These 202 and 750 notes are just examples where we've made removal of surfacing and base and replacement of aggregate incidental to other bid items. These are small quantities, and the more you can make incidental, reasonably make incidental, the easier life will be. The contractor has a responsibility to maintain access to, not just to the corners they're working on, but access in general to the project corridor. And the way we can help with that is by limiting how many corners they can rip up at any given time, by limiting the amount of traffic control they get. Then of course, their plan is probably subject to approval by the engineer, but we don't want them coming in and ripping out 30 locations at once and pedestrians having no options. The last note on this page, in Grand Forks, we require reinforcing. We put steel in our curb ramps. Part of ADA curb ramp is not just building it, but maintaining it. Businesses and cities, municipalities, they're clearing snow with skid steers and other equipment. We found that putting rebar in reduces cracking and faulting and saves us some maintenance in the future, hopefully. The last plan note is we've written this landscape prep note to be used. Basically, it just, when you do form work and replace sidewalk, they're going to have to do some removals of topsoil. It's all got to be replaced and reseeded. This kind of takes all of that, all of the grading, all of the replacing of topsoil, puts it under one square yard bid item. And of course, we tell them that the estimate is based on 2 feet each side of the sidewalk they replace. But if you're doing some serious elevation changing, you might need to give them additional space. And then one note that I included in my last set of plans that I didn't see on recent plans, on the layout sheet, we were telling the contractor that any ramp found to be in non-compliance after it was finished was to be replaced at their own expense. Again, no plans are perfect. Sometimes changes happen in the field. Sometimes things happen when finishing, but everyone from the designer to the inspector to the contractor has a responsibility to make sure these ramps are compliant when we're done building them. And I think this is a good note to put on your layout sheet to remind them when they're building it, they have a responsibility too. One other issue, a known issue, and a reason I harped on everything goes back to ProWag and to keep refreshing yourself on ProWag when you're doing this work. There is a known issue in our plans. Jen is working on getting the standard drawing updated, but the detectable warning panel cannot be more than 5 feet from where you enter traffic. And our drawing kind of shows tilting the warning panel. And this has been determined to not be acceptable. What ProWag expects here under 305.2 is that we will tilt this ramp all the way to, if we're more than 5 feet, we're going to bring it all the way to the back of curb and kind of trim it so that the detectable warning panel extends the full width of the panel. I can't imagine trimming panels is going to be popular, so I just wanted to throw out here. We don't show radial panels in any of our standard drawings, but they are out there. They exist for a reason. Maybe a better solution to ordering a larger panel and trimming it would be to put a radial panel in. And of course, these are measured at the back of curb for length and radius, and then just labeled in the plans. So just something to keep in mind when you're building these, that tilting the panel does not mean, that means you're not getting your full 2 foot of detectable warning surface, the full width of your pedestrian access route. It's not considered acceptable. We should be doing something like this or putting in radial panels going forward. And then the only other thing to keep in mind is this is a very time-consuming process. The more time and effort you put into good survey and design will mean less issues in the field. But you'll notice here that the plans for this job or for this particular job with ADAs are due in June. However, we already have to know our right-of-way limits by January, so that right-of-way can, do their work. And you may also need information regarding ADAs for some of your other coordination, like historical or railroad, and you definitely need it for your CED. So you cannot think you're going to do this in a short time. You're not going to do an ADA project in a short time frame. You're going to have to be ahead of this so that other divisions have time to do their work as well. And I guess the big kicker here is obviously right-of-way division needs time to acquire permission to do work, and that's where I'm going to transfer you over to Mary to talk about curb ramp agreements.
Let's see here. I am going to share my screen. Okay. Oh, come on here. Are you still sharing, Brandon? No. It says it's loading. Let me get this. There we go. Okay, for those of you that don't know me, I'm Mary Falsing with the ETS Right-of-Way Division. And let's see here. I can't tell if my camera is on or off. Can you tell me?
That's all, Mary.
Okay, thank you. All right. As far as the right-of-way acquisition portion of it, that's what I'm going to discuss with you. So I'm going to kind of go through the whys and what fors, why the curb ramps were created, and then we'll get into some of the documents. Ray Barchinger is our program manager. Give a shout out to him. He's been with the DOT for quite a long time, and he played a major role in creating these curb ramps. The first slide here shows a long sentence for projects that are considered regarding improvements and alterations, and within the existing right-of-way and the examples would be overlays or concrete repair or microsurfacing. But in my mind, to simply state it, curb ramps are used for removing and replacing. They are not used for new construction. And I apologize for my voice, you guys. I've been fighting a cold, so I hope you can hear me okay. The benefits of the curb ramps, the milestone dates basically stay the same for curb ramps and exhibits as it would for plats. So once you have your design and your limits set, like Brandon had said, you need to get that information to us so we can do our title and start our work at our end. one of the benefits of curb ramps is the right-of-way survey is eliminated. Now, everything that Brandon went through, you still have to go through all your design processes and surveys. But when we do curb ramps, means we're removing and replacing in like, you don't need to include right-of-way limits on your exhibits. The legal descriptions are simplified. If John Smith owns lots 1 through 4, but you're only working on lot 1, the title will show that he owns lots 1 through 4, but the exhibit will show that you're doing the work on lot 1, because that indicates to the property owner that you're only going to be accessing that portion of his property. You're not going to be going anywhere all over the entire property. The title basically follows the requirements for a surface ownership report or an SOR. We require the 2 last vesting deeds and a copy of the tax statement. And we request the tax statement because it gives us a property ID number, and it also typically has the most current mailing address for the property owners, because the deed, if they bought the property 15 years ago, it isn't going to always have an accurate mailing address on that. The curb ramp agreement was constructed for light construction traffic to set and remove the forms and to restore the vegetative grass. You are not installing any permanent features like Brandon indicated, that retaining wall. And the agreement also has a portion in there where it's the property owner has to mark a yes or no box indicating that they are or are not giving you permission to be on the property. And these forms are not recorded. It's a one-time minimum payment of $300 per property owner. So if one property owner has 2 or 3 different curb ramps, it's still a one payment of $100 or $300 for the one property owner. Being it is a small enough amount, the mortgages are not considered, so we don't have to worry about any of that. Curb ramps are voluntary. We will not condemn on them. So on the form, if the property owner checks the no box and says he does not want you on his property, then we will not be performing that work. And all of our work at the right-of-way division all follows the Uniform Act, and none of those requirements are changed. This is an example or a copy of our curb ramp agreement. And in here, it tells you, and I strongly recommend to everybody to please read through this agreement, because this agreement tells you what we will or will not do. It talks about the no permanent features, and it talks about revegetating the grass. And then on the second page up here is where it indicates that they grant permission to access to the agents to enter our property for the purpose and manner described above. And they have to mark this yes box. Otherwise, we would have to send it back. But if they do, like I said, check the no box, then that means they do not want the project. It's a very basic form. Project PCN, curb ramp number or numbers, and the ownership information. And this is a question that's come up a couple times in the past few weeks. The county is where the project is located. So, for example, if Grand Forks County, and if the people live somewhere else, we don't want them filling in a different county. And so what I wanted to get into a little bit more specifically is we are in the process right now of creating a template for what we require for our projects is a designation map, and then the curb ramp exhibits and street view pictures. And so in the past, we've kind of let the different engineering firms create their own format. But now we've been having issues with some of the information not being the way that we would like to require it. So as soon as we get that template created, it'll be given out to everybody. And also all submittals, we prefer them to be on the 8.5 by 11 size. We don't like the legal size or the ledger size because that way they just all fit right into the packets. Oh, went too far. Okay. This is an example of a project designation map. It does not have to be a professional format like this. It can be a Google Earth picture with your curb ramps indicated, but we do like to have the project from start to finish. Here's the end and here's the other end. This one had 3 curb ramps, and in this particular case, one of them was eliminated, but we like to have a map showing us with the addresses and street views so that we know where these properties are at. One fella had even submitted one time from like a plat map or the addition of where the curb ramps were going. So this is going to be the first page in our template where we're going to require a designation map. Then the next one is an exhibit example. This is what we're looking at putting into our template. We're going to want street views, and this one could be designated a little bit clearer, and this is something that we'll work on with our template. But the curb ramps need to be designated and numbered. And then down here on the bottom, this is the type of information that we want. We want the owner. Now this one says address, but it'll be changed to mailing address because we want to make sure that all of our documents match all the mailing addresses. This one here says parcel, but we're going to change that to physical address so that if it's different than the mailing address, in here, we're going to do just a brief description of the project. And then over here by the legal description is where we put in the PID, the property ID number from the tax statement, so that we know we can't just take a tax statement and go by a legal description and know we're in the right area. We have to have the ID number to go with it so that it all correlates. And one thing that I have in my notes is if, for example, you do have 2 curb ramps on one corner for the same owner, we do want an exhibit and a street view picture of each curb ramp. And then the last one is the street view example. And this again is just an example that we're using to generate our template. Here's the street view showing these 2 street ramps, curb ramps. The picture could be a little bigger, but this picture is very acceptable. It shows everything that we need. And the same information block will go at the bottom of that. Let's see, what else have I got here? Well, let me bring this back down. Some of the most commonly asked questions is, can the LPAs use these forms? And yes, and they currently do. So if you're working with local government, they have access to these LPA forms and they can forward them to you. If this project has already been surveyed, do they continue with plats or switch to this process? And my answer is, it depends. Are there other TCEs or fee acquisitions involved? If you're already going with that aspect, I would recommend staying with the TCEs because the minimum cost for a TCE is the same as a curb ramp. It's a $300 fee. But if you're doing a project and you started out with plats and you're doing nothing but curb ramps, you could simplify it down to the exhibits. Don't be afraid to call and ask and explain where you are with the process, because either your right-of-way contact person or even Ray, if you ever have questions on these what-if situations where alternatives could potentially be used, we would prefer that you call and discuss them with us rather than try to just squeeze things in with the unknown. And do we need a curb ramp agreement if work is done with an existing right of way? It depends, because sometimes the existing right of way goes to the edge of the sidewalk, and if you need to go beyond that parameter, excuse me, I'm sorry. You need to set up your forms, and you have to have an area for the workers to have access to the area. And that's why the curb ramp was created. But otherwise, if all the work can be done within the right of way, then you do not need to do the curb ramps. It's just you have to give yourself an adequate amount of workspace. I know I went through that really quickly, and it's because I'm trying to not talk too much. Is there anyone that has any questions? Feel free to contact me. I just realized that I did not put my information at the end of the slides. Again, I'm Mary Volsing with the Right of Way Division, and Ray is our program manager. And if I've missed anything, or if you have any questions, go ahead and send it in, and we'll get answers to you as soon as possible. And with that, Jesse, I don't know if you have anything else, or if anybody has any questions.
Yeah, maybe we'll hold on for questions. We got one. We got Devils Lake Steel 10 minutes from them, so we got one last piece. Ethan and Mark are going to cover here. Thanks, Mary. You did a great job.
Okay. All right. Thank you.
All right. Can everybody hear me? So, all right, we got confirmation. Thanks. So, like I was mentioning, all the preliminary survey and design has been done. Winter has passed, and now we're out in the field. So, Mark and I are going to talk a little bit today on construction inspection. I'll be starting it off here today with a little field verification. What field survey should be provided to contractors, what factors and constraints are involved, and kind of what level of responsibility does the contractor hold. And then Mark will be digging deeper into the construction of the ramps themselves. So like I say, first thing, you walk out the field, the left slide here, what you're being shown is your existing conditions, and on the right side is the design that was given to you. So it's time to implement what has been designed for you and make sure that design actually meets the field conditions. So first thing you want to do is check your removal limits, because that kind of sets your boundaries of the full completion and construction of the ADA ramps. So ultimately, you're given elevations here based on your survey points. You're given your slopes. Everything looks good, but nonetheless, it's good to go out there with your smart level and tape measure. Check these widths. Check these slopes. Say an elevation was missed and you need to excavate another panel or two back. As Mark's going to cover pedestrian safety measures, you want to make sure we have our limits figured out before that gets set up. So the next page here is kind of a continuation. This is the same imagery, but it's showing what else is given to you on this particular plan set. So given your points correlating with your locations, like 9,024 here, you can come over to point 9,024, gives you your elevation. You can come over to this one and check the slope, indicating if this slope is correct or not. Now, you're not always given these elevation points. Sometimes consultants, the DOT will or will not provide these. And even as Brandon, I mentioned earlier, if these are shot with the GPS, you could be off, up to 500, which would throw your slopes off. So it's to reiterate, it's good to check these with your smart level, or even if you have a laser level, go and check these points and just reiterate that all these locations and elevations can be met before all your removals are set in place and even forms are being built. So you know, each contractor is going to be a little unique on how much they request or require for assistance from inspection on survey limits. You know, one contractor may come in and provide everything themselves as far as survey, and some may require a little more assistance, but ultimately at the end of the day, it's best for all parties that this is installed correctly the first time. But you know, the notes being shown here, these are similar to Brandon I mentioned, so you know, kind of the responsibility of the contractor is that any ramp found to be in non-compliance will be removed and replaced by the contractor at their own expense. And then it's also reiterated here that dimensions shown may vary from actual. So a contractor will field fit adjust if max slopes cannot be met with dimensions. So, you know, obviously there will more than likely always be some slight variations. So you want to work with your contractor, you know, looking how far back into the east side of the right-of-way here we are. You know, if we need to pull back farther into the city's right-of-way, that'll be something that would have to be discussed with them. Or if there's any further constraints, you know, a lot of examples of constraints, there could be utilities, there could be more broken sidewalk, there's countless issues you can run into for constraints on that matter. Here's kind of another example we pulled out of plans and as-built plans, as-built plan set. So here you're given your removal limits. The as-built's found out, you know, it just need to be 6 feet versus the 5.5 feet wide. So those are little known issues that can come up. That's, you know, that's going to vary for your quantity of removal limits, your concrete that's going to be utilized. Another good example, this one is a pretty good example of how differing design limits versus what was actually out there. So on your left here, you can see your existing conditions. It was pretty well sloped. There was a light pole in the location here, which was indicated. So the removal limits were given about, you know, 17.5 feet back, which ultimately with the 15% known slope there, the contractor and the DOT or inspector for that matter had to pull back another 17 feet to match in to the existing sidewalk back here. And like Brandon mentioned, you know, we're not in the business of correcting sidewalk here, so you kind of got to be a little careful on how much you take out, but there is the rule of the 0.5% per foot, right? And now we had 15%, you know, we couldn't be matching into a 15% sidewalk and leaving, you know, per se a 3-4 inch lip, right? So ultimately what was decided upon and performed in the field is this was carried back further to match in. So that's a pretty prime example of how conditions are changing in the field. And checking, you know, this should have been checked beforehand when you got in the field, and this would be known so you're not chasing it back with the contractor, taking panels out one by one as forms are being set. Kind of another smaller variation in plan sets. As you can see the removal limits and the as-built here. It was shown to not remove some curb and gutter around this little location here, but ultimately for performing the removal of the concrete around there, it ultimately ended up in the curb and gutter having to be removed similar to this location. So, and that's really all I have for doing field verifications, just to make sure everything meets the plan and you're aware of how much needs to be removed initially. So from there, I'll kind of hand it off to Mark. So.
Okay, can everybody see that and hear me?
Yep, we can hear you, Mark.
So I'm going to take you into the field now. We're going to construct some ramps. I'm just going to be covering some of the more common topics of ADA construction that seem to raise the most issues. So we're going to go through safety, order of operations, placement, utilities, drainage, and joint placement. So first of all, you need traffic control set up, not just for cars, but people. It's especially important in congested urban areas. So here, This is on Demers Avenue downtown, so we actually decided to add chain link fence to this project later on around the construction limits. We had a lot of pedestrians that were not willing to use the accommodations, so that was a necessity. Always check that the devices are in compliance with your standard specs. It helps to sit back and watch, but having issues with detours. Also verify that the contractor will have enough room to complete removals without having to readjust your pedestrian devices. So, order of operations, you need to pour certain things before others. Landings and curbs come first. Ramps, transitional panels, and detectable panels last. Believe it or not, I've had a contractor ask if they can pour the whole ramp at once. Well, obviously the answer is no. It's also covered in the 750 plan note. Note also states to allow landings to cure at least 24 hours before constructing adjacent concrete. Be sure they follow that rule. Placement. So your surveyor is going to come out and set stakes, or you are. Be aware that survey stakes will be disturbed during construction, and be prepared to have them reset a lot. You're going to have to keep an eye on that quite a bit. Sometimes you have electricians coming in and setting conduit or whatever, and they take stakes out. They don't tell the concrete contractor, and so things get left that way. Also verify that steel reinforcement was laid out correctly. Base materials compacted. Go over the plans with the contractor prior to removal, so just to ensure they know what needs to be done. Don't assume they always know. Surveyor can stake it one way and the contractor can pour it another way, so make sure they're following what the stakes say. Also, sometimes more than one contractor will be working together on a ramp. So care should be taken on behalf of both crews to preserve each other's work there. Like I said, sometimes things get destroyed and left unsaid. So if you don't see it, didn't happen. Utilities, be on the lookout for utility conflicts not called out in the plans. Brandon said there will be a utility SP coming soon, so that's good. Urban settings will always have some sort of utility within the sidewalk. Sometimes multiple underground lines need to be rerouted or installed brand new. Curb One is a nice tool. Use it where it's needed. Sometimes the plans don't account for all of it, so be aware of that. Like a good example would be signal-based footings that are too high. So if you're going to retrofit a ramp, in order to meet elevations and grades, you may need to put some type 1 around that base. And of course, don't forget to put expansion around your bases. Make sure your push buttons are compliant and in good working condition before and after construction. Preventive maintenance plans will not include underground or above ground utility work. Sometimes we have to retrofit around push buttons while we try not to break them. So on reconstruct projects, make sure all underground work is completed before pouring ramps and sidewalk. And drainage is an important one. Double check that your flow directions are correct in the plans. Work with the contractor to make any adjustments to your forms or grades and steel placement. Also, is it draining to the right place? Joints. Be aware that sometimes cracks will appear days to weeks after the concrete has set. So these should be included in the list of punch list items and addressed before the project is finalized. You want to make, these chalk lines, you want to make sure. So we left a chalk line here without cutting it. So you want to make sure they all get cut. Sometimes you're going to have some random cracking on these curb flares. They tend to do that, especially if they come to a sharp point. So one of the golden rules is no sharp triangles. And just make sure all your lines have been cut. Sometimes they leave your chalk lines uncut. You know, check the depth. So that is all I have. We will turn it over to Jesse.
Yeah, we're running pretty late on time here. I don't like cut too much in Devils Lake, so I'll just a few things we look at for when we do our final inspection. You know, this reason why I brought this topic up, that there's a lot going on in a small area, tight tolerances. A lot of things have to go right to make sure you construct a proper ADA ramp. Brandon mentioned earlier, as far as the 4-foot minimum par width for your panels, but one thing I want to touch on is you have a designated shared use path, you have to match that width. So if you have a 10-foot shared use path, that panel needs to be 12 or 10 feet. So it's some of the things we see in the field sometimes where those panels aren't the right width, and then you got to start back all over and replace that. So that creates issues and headaches for everyone. So just a lot of things to look at. I think when I brought this topic up, Jason Fisher said he could probably spend 2 full days on this. So it's a lot of information to cram in an hour and 12 minutes here. So I guess we could maybe take a quick question or two if anyone has one for anyone in the group, and then we'll turn over to Devils Lake. Hearing none. Hey, Josh, you want to turn over to Devils Lake? I guess we're good.
Thanks, Jesse. Thanks, Brandon, Mary, Ethan, and Mark. Yeah, we got Devils Lake on up next. Is it Chris or Darren?
It'll be me starting us off.
Sounds good. Go ahead, Darren.
Okay, good morning, everyone. Looks like our presentation went away. Okay, we're gonna talk about bridge deck overlays. I'll say the disclaimer right away, we're not real experienced in bridge deck overlays. We picked this project this topic because we were supposed to have a set of 3 of them this summer, but with all the funding stuff, they got pulled. But our guys did a good job of researching and putting everything together. So some discussion topics we're going to go through. Dustin Legacy is going to talk about the chaining and the survey of the bridge decks beforehand. James Wren's going to go over some of the different demo methods. Brian Bennis is going to fill us in on materials, and then I'll finish it off with the paving and finishing. So I'll turn it over to Dustin Legacy.
Good morning. And I guess I'll start off talking a little bit about the chaining. I guess we went and chained one of the bridge decks that we're going to be overlaying here in this near future with that project Darren was talking about. So the bridge deck's on Highway 17, just east of Candu. It was built in 1962. So, and I guess in our next couple slides, we took a video of some chaining, which you could pick out the sound fairly well. So as the video come up to get played, you may have to turn the volume up a little bit to, I guess, hear it. For anyone that has not experienced any of the chaining. So here we got our own Dennis Horn doing the chaining here. James Wren watching his back. This was done on I guess a low volume road, not a lot of traffic, so
if you get on a bridge that does have a lot of traffic, you're definitely going to want flagging involved. That way to keep the traffic off the bridge as you're doing it, because sometimes it can get a little tricky picking out the different sounds. But if you listen close, you can kind of hear the rattling when he hits over some of those spots. And then we have one more just quick little video too, that I think it does pick up the sound just a little bit better, but so upon completion of doing the chaining, getting everything painted up nice and getting all your delamination areas marked out, we'll go into kind of surveying them and getting the areas of everything. And when it comes to doing the survey, I guess you got your old conventional way, pulling out the tape and drawing and hand calcing everything. And then you can also go out, take the GPS out, shoot, and then shoot the corners, bring it into Trimble Business Center, and you can figure out all the areas that way. And then we also have the option of flying the drone up there, getting an aerial photo, and bringing it into MicroStation. So since everybody more than likely knows on drawing some nice pictures and measuring everything up and hand calculating everything, we'll kind of touch base on the GPS a little bit with Trimble Business Center. So I guess we'll shoot to all the corners, and then every little change in direction, if you got an oddball shape, or you shoot to every corner where it changes direction. And I just typically just use a break code. As Brandon mentioned earlier, you can put your linking codes in for your start and joining or closing the shape out, and then shooting all four corners of the bridge to get the total bridge deck area. And once that's complete, I just bring the file out of the data collector into Trimble Business Center, and you can then you can start bringing in our feature code library to generate the line work, go through and make sure all the shapes are closed. And then once everything is closed, you can select all those lines and shapes and then bring it into a report that will give all the areas. So the next slide here, that's kind of what it looks like in Trimble Business Center with our line codes. So I got the total bridge deck area, got all our shapes of the bridge, or of the delamination areas. So then in the end, I can select pretty much all those shapes. I can go into our reports, click more reports, and then there's an area length count report, I believe is what it's called, that will generate all the areas. And then depending on your settings, it'll either generate in square foot or square yards, what you have it set at, which then that will bring in the total overall square yardage of the deck, and then each individual square yardage of the delaminated areas. So, and then with that, we can also use the drone, which out in the field, it's quicker. Just fly it up. And I guess before starting your flight, you should always verify on whatever air map you use for creating lances or any of that, just to make sure there's no restricted areas. Everything is type G airspace. which majority of North Dakota is, but it's always good to check. Then you'll start your UAS up, fly it, get over top of the bridge, make sure you can see the whole bridge deck, have the camera down at a 90 degree, and then snap a few pictures. Make sure you can't have too many, I guess, so take some pictures of the scenery if it looks nice. And then after that, we'll bring it into the computer. And then we can drag that into MicroStation so you can copy and paste it, or you can bring it in as a reference. But it seems like when I copy and pasted it, it seemed like it got more pixelated and I had a harder time picking up the paint versus when I referenced it in and merged it into the main file. And then you can see the lines that I drew in MicroStation, which since we had shot it with a GPS and with the drone, I brought the GPS points into MicroStation, which are the red dots, which after my scaling and with the picture with the width of the bridge deck, I guess you can see that all those lines come in pretty close. So it's definitely a good way of doing it. Keeps the people off the bridge as much as possible. So that's the other thing when you do fly it. I guess you should know the width of the bridge deck for scaling. I guess length too if you want it, just to verify that it's scaled properly, but you can just take a quick measurement of the width. So here and then with the MicroStation, you can bring it into you can put it on a nice little plan sheet. You know, you can put the bridge number on it, what date you chained it, any other information you want, you know, weather. And then the total, on this one, the total area of the deck I have on here is 326.6 square yards, and the delaminated area come out to 13.5 square yards, which put us at a 4.2% delamination. So it's definitely a useful tool, and then you can put it on a nice plan sheet and for future, because then typically we put them on a plan sheet, and then we've also put all the pictures we've taken out in the field with iPad or phone, created them into a PDF, and then just linked it all into one little packet for easily accessible. So I guess that's about all I have. I'll turn it over to James Wren for talking about some of the bridge deck demo.
Good morning, everyone. We'll do a quick overview of this, and most of it's pretty routine, you guys all know. Well, we'll start with the preparation and asbestos inspection. If any asbestos is found, you'll have to contract out a removal service. And we move to the removal of structures. When removing bridge elements, they're designated for salvage. Each element must be match marked and transported to the specific location. Substructure removal. Existing substructures need to be removed to 1 foot below the final ground surface, depending on the location. Measurement and payments, that will all be outlined in the plans. And specific equipment for demolition, such as pneumatic hammers, hydro demo equipment, must meet certain criteria for safe and effective removal. When we get into the types of equipment or types of removal, start with the milling machine to get an even surface to a specific depth. sometimes pneumatic hammers and jackhammers will be used. The removal with the hammers and the cutting saws need to be real specific so you don't cut through the rebar and other structures. Hydro demolition, which is considered to be the safest and most cost effective. Just blow out the bad parts. They wouldn't let me try any of the explosive removal, so I can't speak to that. And the classes of removal, concrete will be milled to the depth in the plans. Area will be checked for further removal, determined based on the condition of the removing concrete. After that, you'll have your physical conditions of existing concrete, sorry. Class H, after completing class 1H removals, the engineer will check the deck, identify any areas that need a second pass for hydro demolition equipment. Following the 2A or 2H removal, the engineer will check the deck again to determine areas that require a third pass. General construction requirements, ensure there's no damage occurs to the remaining reinforcing steel during the removal process. And of course, safety tops all. And with that, I'm done.
Okay, looks like we're moving on to materials. I'm just going to touch on a few of the materials used in the bridge deck overlay process. We'll quickly go over the mix design, some aggregates, specifications, the cement, and some of the testing. You'll receive a mix design, which is a double AE5 mixture. It will contain cement, coarse aggregate, fine aggregate, water, air entrainment, and water reducing admixture. After the mix design has been approved, generally production can begin. The aggregates, the contractor will bring the aggregates to the site, placing them on the roadway on either end of the bridge. That'll be a coarse size 5 and a fine aggregate. The concrete will be an AE5, and you could use an overlay concrete, which will consist of a crushed stone with one face 75% fractured on the 4. The aggregate will be in the 2 stockpiles. Samples of each of those aggregates will be taken by the DOT for acceptance, gradation, and physical properties. This is the spec that you'll be following, the size 5 requirements. And the physical properties you'll be looking for. The only difference on the course will be the iron oxide particles will be 2.0 instead of 4.0 for bridge deck overlay. Cement will be in bulk bulk semi-containers on the roadway. 1 15-pound sample will be submitted to Materials and Research for testing. The type of cement used will be a 1LMS. which is a type 1 Portland limestone and a moderate sulfide resistant cement. This is a picture of the bulk truck that you'll see on the roadway where you'll obtain your sample. This is the cement. This is the volumetric mix truck. You see the 2 compartments in the back, which will hold the fines and the coarse aggregates. Number 2 on the slide is where the cement is at. Number 4 is your admixtures. Number 3 is your water. 7 is the belts that carry the aggregates down to where it will be mixed with the cement and water, which is where number 9 is, and the finished product comes out at 10. Calibration of this unit is done based on the specification here: 500-pound capacity platform scale, 300 pounds test weights, a container placed on the scale, and a deflector to divert material from the mixer to the container. This is another photo of the volumetric truck being loaded. This is the buggy, which will transfer the concrete mixture to the bridge deck. A pump truck can also be used. It cannot be used with a latex modified concrete mix for the bridge deck, but it can be used for the other materials, as well as a belt placer. Normally, we don't see any of those. The buggy is what is most commonly used. Here's another photo of the volumetric mix truck loading a buggy. The acceptance testing, you'll see sieve analysis of coarse and fine. That is generally taken once the material hits the roadway. The DOT will sample that for acceptance. During production, slump, air, unit weight, and some cylinders will be made. This is usually done with the first load going out, and then every 50 cubic yards after that. The air entrainment is 5 to 7, slump is an inch or less, and then you'll also run a unit weight. Cylinders are made, one set per 50 cubic yard. We'll be looking for 4,000 PSI in 28 days. And the IA testing is a minimum of 1 per project, a split sample of the coarse and fine. And then we will go out and do a slump, air, and unit weight. The testing tolerance for IA is listed here, plus or minus 5 on the 4, 8 to 50, we got a plus or minus 3, 200 plus or minus 2, and then the slump we got plus or minus an inch. The air is plus or minus 1, and then we got 2.5 pounds on the unit weight. That is the correlation between the field and the IA tester. And in a nutshell, that is materials. Now we're on to deck paving and finishing.
All right, thanks, Brian. All right, we'll move on to actually placing the overlay now. I'll go over a few of the general requirements. Want to go to the next? One of the first things you want to do is some surface prep. After you've done all your removals, you're going to want to sandblast the deck, remove all the loose concrete and clean all the reinforcing steel, get all the rust off of it, any loose concrete, get everything cleaned up real well, and then blow it off with compressed air. You also want to make sure the surface is completely dry. You can do this with compressed air. No using burner torches or anything to get the water off. Just compressed air And then you'll also, after it's all dry, then you can place your grout mix on there and work your grout mix in. And this is basically a bonding agent for the concrete to make sure it sticks. And you have to get your overlay on before the grout is dry. So it's not something you can do a day ahead of time. You do it right before you're placing. Then your finishing machine, your finishing machine, your overlay stuff will run on rails on the side. So you have to work with the contractor to make sure the rails get set correct and get everything set for the profile. And then make sure the contractor does a dry run through to make sure all the profile's right and the screed is running at the right height in all the locations. Because it's a lot easier to adjust it ahead of time than once you're placing concrete. One of the weather requirements, make sure the air temperature is between 45 and 80 degrees. We don't want to be placing overlays when it's too hot out. So a lot of times you'll see the actual placement done maybe early in the morning or maybe late at night, so that you're not getting out there when it's too hot. And then, as Brian mentioned, placing the concrete, generally you'll see contractors using buggies, and they'll just keep running back and forth from the mixing truck and lay it in front of the paver. And then you want to make sure that everything's done in one continuous operation. Don't want to leave any transverse joints in the bridge deck. So want to make sure everything's set up. You have enough material and everything you need to keep everything going all at once. And then if you need to afterwards, you can finish with a wood float. You need a little adjustments. And this is one area that make sure the contractor isn't out there using water to help finish. I'm sure everyone in the field has seen the contractor out, we call blessing the concrete, getting a big brush wet and flinging water on it. This is definitely a no-no on bridge decks, so make sure they're not doing that. Then we get into our curing process. You're going to want to make sure it's cured for at least 5 days and make sure the concrete stays above 55 degrees during that cure period. We're going to cure it with a double layer of burlap, and you're going to want to pre-wet your burlap before you place it, and then place your burlap within 15 minutes of placing the concrete. You'll lay it in with, generally the contractor will have platforms moving behind that want to run on the same rails as the paver. And that way they can work over the top of the concrete and not have to walk in it or anything. But you want to get your burlap on, and then it has to stay wet for the whole cure period. And no traffic or work should be done during the cure period. So keep everyone off the bridge, all the traffic, just the guys that are out there that keeping the burlap wet. And one thing you'll see maybe other states do, we don't allow it, is don't allow them to put plastic over the burlap to hold the moisture in, because the plastic can act as a insulator basically and create a greenhouse, and you can cook the concrete. So don't allow them to put plastic over it. If you're placing the concrete in colder temperatures and need to create an enclosure, make sure that it stays heated constantly. And then when you do take the enclosure down, make sure you let the temperature gradually decrease. Don't just open it up and shock the concrete. Oh, then once everything's cured out, then you can go and check to make sure everything is correct with the concrete. Use a 10-foot straight edge to check for irregularities, any bumps or anything like that. I'll go through and check the deck and just make sure everything's good. Any areas with a more than 1/8 of an inch of deviation and less than 1/2 an inch, have to have the contractor come back and grind it till the deviation is less than 1/8 of an inch. Anything over 1/2 an inch, they'll have to look at the serviceability and the constructability, of grinding it, whether you can do it or other corrective actions are going to have to be done. For any of that, make sure you get a hold of Bridge and get them in on the discussions. And then if need be, there's contract price adjustments in the spec book for any of the deviations. So make sure you're looking at that and applying anything that's applicable. And then here's just a list of some of the specs that go along with the bridge deck overlays and the finishing with your equipment and the different placing specs and the bridge deck overlays. So things to look at. And I think with that, we got some time for questions. Any questions or comments out there? I know there's other districts with a lot more experience in bridge deck overlays than us. So if you guys got any great advice, we're willing to take it.
I think Darren, I don't know if I have a question, but I know going back when I did a deck overlay, and I think the comment of making sure you get a hold of Bridge timely is pretty crucial. I had a bridge, or we had a couple bridges that had a rounded crown, and it didn't really show in the plans if that's what they were, but a contractor showed up, started milling, and the rounded crown probably wouldn't have been a problem. Excuse me. But when they on one of the decks, the rebar floated when it was originally constructed, so we started hitting rebar right away. Well, I didn't necessarily go to Bridge right away. We just managed to remove what we could for the bridge deck, and then went back and adjusted the risers and probably put more concrete on that bridge than was originally intended. And after it was all done, then it obviously came to note that the bridge, actually, you're changing the legal weight, or the dead weight of that bridge, and you're going to change what legal weight can actually get over that bridge. So I think I just make sure everybody realizes that if there's something not quite right, don't be afraid to reach out to Bridge or get some advice from them on what to do. Eventually it all worked itself out, but it was just more concrete bridge deck on that bridge that we probably first intended it to be. So thanks.
That's some great advice, Wade. Yeah, you definitely keep Bridge involved anytime you're working on bridges. Anything you're doing, if something doesn't seem right or you have to deviate from the plans at all, just make sure they're in the loop, because they're the experts, and any small change in a bridge can be major. So that's good advice. So If there's no more questions, I'll turn it back to Josh. You're muted, Josh.
Sorry. All right. Thanks, Darren. Thanks, Dustin. Thanks, Brian and James. That wraps it up for this week. We'll come back next week. We have Dickinson starting us out and the ND Safety Council on trench excavation safety. So thanks, everyone.